So I got a little bit too excited and I opened up this box already, but we're gonna pretend I didn't do that. So this is the reveal of the new generator. That's going to be hooked. This generator head is going to be hooked to that engine, which will end up on that trailer. This is a 60-degree V6 GM from the early 90s. And this is a landscaping trailer that will be the new home for both the engine here, as well as the generator head. So the next step is hooking the generator head to a V6 engine that does not have the correct bell housing. So we're gonna build that. We're gonna make that work. How? I don't know yet. We're gonna figure it out. These are the valve covers that I took apart or took off and bead blasted quickly. This one was really bent up and I had to straighten it up on the edge here because when I lifted the engine, it crushed it with the engine lift. They look okay, not fantastic, but it's a generator. I don't care that much. They're gonna work great. As you can see here, these are some mounts that go to the engine. This engine was actually mounted on a stand. You can see this piece here. And this here is the back. It's kind of a tripod situation where this hooks to the bell housing bolts on these 2 points right here. And this hooks to the motor mounts of the engine, which are sitting right there. And that will hold the front up. You can see here that I have a clamp holding a pipe across the bottom of the trailer. It's a little bit hard to see with this box on the way here, but there is a pipe that's going around here, right here, all the way across to this side where it's held on by this clamp. That will be the front mount for the engine. The rear mount for the engine will be on this cross member here, which is already, came with the trailer itself. That puts most of the weight in the front on the tongue. I need to still, I think I did the calculations with a different generator head. That was a much heavier generator. So I will have to work with the new weight, which is, it's a difference of about 300 pounds. So I may have to move it back slightly to get the offset that I'm looking for and the correct tongue weight. One thing to note is I do not plan on driving around with this on the streets. This is largely for ease of just moving it away from the house when it's not being used, or moving it to wherever you need it. That's going to require a hoist. actual bell housing of the engine. As you can see, that is not going to work. So we're going to make it work. So that goes on there. That's going to be its new home. I think this flex plate can be cut down on the mill and then adapted to the back of that flywheel to bolt onto the bolt holes for the clutch. Starter already engages the clutch, so that should be fine for that. And then the next step is to figure out what goes between this bell housing here and that bolt pattern there. And that's going to be looks like something like an adapter plate slash spacer type of situation. This is kind of our first look at how this is going to go here. It's not exactly the exact angle, but it's pretty close. So there will be an adapter that goes between here and here. This will be cut down to fit the bolt circle that is on here in the mill. And then something will bridge the gap between the bolt holes here and the bolt holes here. We don't know what that's going to look like yet. I want to talk a little bit about how this thing is going to run. So it has a carburation manifold on it at the moment. I ordered a multi-port fuel injection manifold from eBay. I found a pretty cheap one. Now it's off of basically it's a Fiero type, which is like a 3-piece intake, which I don't know that I want to use. But it came with the injector rails, I believe a set of injectors, and probably enough of the plumbing that I can piece together injectors onto this manifold, which means I'm going to mill the bosses into it and put the injectors into make it multi-port fuel injection. This has to run at a constant 1800 RPM. I'm not worried about horsepower. I'm not worried about how little these holes are that allow it to breathe. It doesn't need that much. But it will run an aftermarket fuel injection system. I'm not sure which one yet. Maybe a Mega Squirt multi-port. When I initially fire it up, I will just use this distributor as is. Eventually I may go to like a coil per plug or something like that. We'll see. It may not need it. Due to the constant RPM, I probably don't need a whole lot of adjustability on timing or fuel. So tune it at that RPM and right around that RPM, and you're kind of done. It doesn't need a whole lot. Not like an automobile would require under all different loads and so forth. You do have to tune this for different loads, but only at 1 RPM. So that makes it a heck of a lot easier to manage the fuel system. You need idle, and you need 1800 RPM, and you need startup, and that's it. Speaking of controls, got some new spark plugs for it here. I also picked up, these are pretty cheap actually, much cheaper than I expected. These generator controls, speed controls, that are much more reactive than, for instance, like an ECU or something like that. So this will physically control the throttle with a servo. We won't take it completely out of the box here, but there is an electric actuator in there with an arm on it that will control the throttle butterfly based on the RPMs that this is picking up. and it uses the teeth on the flywheel. So there are, you know, over 100 teeth that it can use to decide if the RPM is changing, rather than just the more sparse pickups that you would get on like a reluctor wheel or something like that. So every single one of these teeth on here will be detected, and it will be able to know between every 2 teeth that the RPM has slowed or increased, and be able to adjust the throttle directly in response to that. So that's basically just a big PID controller that's just going to go ahead and make the engine run as close to 1800 RPM as possible, regardless of load. So that's the control scheme. I'm still lacking a fuel tank. I'm still lacking a radiator. I have an alternator, but I will probably need to go through it and put a couple of new parts in it, new regulator and probably new bearings. It's been sitting outside for probably 20 years, as with this engine, which was also sitting. This engine was from a college, and that's why it was on a stand. It was probably built by students back in the early 90s, and then probably sat there for 10 years, and then my father got it, and it sat there for the rest of the time. So I just got it a few weeks back, and I was able to get it to turn over, which wasn't surprising. It was under a camper shell, so outside, but it wasn't getting rained on directly, and the air cleaner was on it, the carburetor was on it, and the exhaust manifolds were on it. So it was saved. It was spared, I think. Anyway, it turned over. I put a bunch of oil in the cylinders and got it to rotate a couple of times over. I'm gonna call that good for now until I hear it run. And then we'll go from there. The water pump actually feels like brand new. I can't even believe how good it feels. But it was probably put on there. They probably ran it in the lab for a couple of hours, and then it sat for 20 years, 20, 30 years. So that's the situation there. Next steps are to try to figure out a mounting for this, and then set the whole thing up on the engine mounts, plus some new mount to mount the alternator on the back of it. And then hopefully that will be one piece that would be able to just drop in onto the trailer. I mentioned in an earlier video that I have this here as a cross member to mount directly to. I may throw that idea away and put some down the center sort of skids that bolt down into the trailer. So that's a one piece that goes in together, rather than putting the engine in and then separately putting the generator in behind it. It would be a one-piece situation where the whole thing drops down at one time. I think that might be a little bit more, I think it might be a little bit better for the trailer. These gardening trailers are probably not that strong on each one of these horizontals. But if I go across them this direction and then capture, three of them or more, I should be okay. And then there will be a radiator mount up in the front here somewhere, right in here, and then probably the fuel tank in the back there. So when you need fuel, you can just pull down to the gas station or bring fuel to the trailer, either way. Well, I have this blasting cabinet here that I picked up to do these parts. It was fairly cheap on Amazon, just over 200 bucks. But I don't like that I can't just roll it around. I like to have everything on wheels, so I've got some wheels there. These are the other parts of the motor mounts for the engine, by the way. So I picked up some angle iron, and I will be making a base for this that goes all the way around the legs, and that allows that to roll around. So that's going to be a little bit of a side project while I figure some other things out on the generator project. So I think at this point, I need to go to the drawing board and start to think about how I'm going to make something to connect these. I need something that's, fairly thick. What are we looking at here? Almost 5 inches, 4 inches. And it's going to have to be very strong too. This thing's, going to be running somewhere around 40 or 50 horsepower. I don't know what the torque is for that. But so this needs to be strong. It needs to be strong enough to make sure that the front of this is mounted to this concentric, so it's not rubbing inside of the generator. So that's going to be very important. So it has to be extremely rigid to the engine, allowing that whole thing to go in together. So I'll have to look around and see if I can find different ways to do this. I could think of, you know, like a strap that goes kind of all the way around with things that mount to it that have bolts in from both sides. It could be a couple of plates with something in between them, maybe welded in tubes or something like that to keep the plates, you know, parallel all the way around. There could be a lot of ways to solve the problem. The question is, which one is the right one? And which one do I have the most parts for that I don't have to buy a lot of things? So that's going to be, this is trying to be a budget project. The engine was free. The generator was not that expensive. The trailer was fairly cheap. And I'm using a lot of used parts on the engine. It's just kind of a quick cleanup to put a little bit of paint on it. That what you saw earlier was just me spraying down some of the little bits of oil off the engine so that I can throw some engine paint on it and just protect it from outside when it sits outside.
We've been living in sin so long, all the feels are gone. Fella stopped me on the street last night, said everything's alright. Roller coaster, make it through the day, I'm right. It seems your meal ticket is gone, but life goes on. I could never imagine something better. Yeah, right. Now you're cooking on high heat in the middle of the street. Roller coaster, take me to a better time. Let's go! All sing your high line with the roller coaster of life. Yeah. It's time to all choose your timeline on the roller coaster of life. You seem to easily forget how to place your bet when everyday life.
This is a standard SAE 3 bell housing, so it shouldn't be too difficult. 18 inches. We have an 18-inch circle. Yeah, no big deal. I need an 18-inch circle of aluminum. So this piece here, this length here, ends up being too short once that bell housing goes on the engine. This is going to be too short, which will not allow the plate to go all the way to the flywheel, but it's a few inches shy. So I believe that I can make a longer version of this piece in the mill that will stick out just a little bit more. Lengthen up the bolts a little bit. It rides on the center here, so I think it should be fine. There's not a lot of side load other than just the weight of this, so I think it should be okay. That will allow me to put a plate onto here. That plate will bolt to the back of that with the 4 bolts that are available on the back of that where the transmission would normally mount. That will go on here first. The flywheel plate goes onto here, and then the whole assembly moves to the back of the engine. And once it's on the back of the engine, the bolts are around this. So you put a couple of bolts in the bottom, turn the engine a little bit, put the other couple bolts in the bottom. Very much like you would like a torque converter for an automatic transmission. I think this starter's seen better days. That's probably going to have to come apart. Or I may actually have one that I can replace it with that's brand new. I believe I have a Chevrolet starter that's just in the box. If that's the same as a Chevrolet small block starter, then and it looks like it is, then I believe I have a new one of those already in stock that it's probably had for 10 years. We'll see if that works. I mentioned previously that the stock distributor off of this engine has a 6-sided reluctor wheel, so that will do 6 pulses for every rotation of the cam. And the cam rotates at half the speed of the crankshaft, so that will be 3 pulses per revolution of the crankshaft. So this distributor here, you can see is not really going to work, since what we need is a number 1 signal. Now there are ways we could do that. We could modify this to get rid of all of the nubs on the reluctor except for one. That would work, and we could definitely do that. Another way is that we can do a little bit of fabrication here where we can sort of stack the two distributors on top of each other effectively, meaning cut this one off, put the other one on top, and use the functionality of the other one on this engine. The bottom of these and the gear are not compatible between the 60-degree V6 and the Chevrolet V8. That is my understanding. I don't know that for a fact, but that is my understanding. If they actually are compatible, then I'll just swap this distributor out with the other one. But my understanding is that they are not, and so I won't be able to do that. So there will be some custom fabrication required to get the appropriate signals out of the distributor here. These engines do not have a cam sensor location anywhere, so using the distributor rotation is the easiest way to do it. It does require extra parts, which is kind of a bummer, but it's easy, it works, and that's probably what I'm going to do. Ready to go anyway. This gasket is shot. Cam lobes look okay. Doesn't look like it had any water in it, which is good, other than obviously the water passages here. I'll have to clean those up with a wire brush and a scraper and use the vacuum to make sure it doesn't go inside the engine. All right, well, we've got it open. Now we're in a good position to be able to kind of look around and see what else we can do here. With the distributor out, I guess I can start to work on that next. I don't know that I have everything, or at least a proper plan to be able to put the generator on the engine just yet. I still have to figure that out. I may do some of that off camera, and then I'll walk everybody through what I came up with. And then you can all tell me I'm crazy and I shouldn't do it that way and do it a completely different way. It's going to be fun. Let's do it. All right, so we've got the distributor out here, and this is off the 60-degree V6. And you can see that there are some pretty major differences here. Specifically, that this is where the intake, this goes into the intake of a small block Chevrolet, or it would even fit a big block Chevrolet. This is a brand new one. I bought this off of eBay for 30 bucks. Can you even believe that? $30 for a distributor for an automotive project. So very cheap. I need these components off of it, as I mentioned earlier. I would like to just
move these components into this distributor. That would be the ideal situation. If I need to machine the distributor, if I need to cut the shaft, if I need to do whatever I need to do, I'll just do that. What this ends up looking like after, at the end of the day, almost doesn't matter. Another option is to cut the aluminum shafts of these two things and then TIG weld them back together, in a configuration that allows the top of this distributor to live on the bottom on this bottom, effectively. There are covers that can go over these because a lot of people use these as the number one indicator. Those covers are just an aluminum piece with a little seal. It just goes on with the two screws and seals this up from the weather. In fact, I did that on my Camaro project. It has a big block with multi-port fuel injection and coil per plug as well. So this one's a little trickier just because on the Camaro, this just fell right into the big block 396 without any issues, and I put the cover on, and I have a number one signal. That's very simple. For this particular use case, it looks like, I'm gonna have a little bit more to do. If we look at the pin to pin distance here, we could see that this reaches up to about here, the shaft, and this one reaches up to about here. So this shaft is a little bit longer. However, this has a longer gear on it, as you can see. The gears actually look fairly similar, with the exception of that long nub at the end of there, presumably to turn the oil pump. So we'll have to figure something out here. It could also be that there's something else to be done here. For instance, imagine this section here, a piece of aluminum either welded on or machined and pressed over this component right here. That gives me this shoulder with the seal right here. Something like that could also work. Lots of options here. Basically, all I need is for the distributor from this point down to look like this. I don't care what happens above here. I just need the bottom to have this gear on it, and it needs this seal on this shoulder here as well as this to bolt it down, and that would suffice. So if there's a way to put that onto this distributor, that would be great. Other options are cutting this distributor down. There's not enough meat here to be able to create something like this, but I could potentially cut this off, build something that looks a lot like this and press it over the end of this to give me something that looks just like this but on here. So I can cut that out on the lathe and put that on the bottom, cut the shaft to length, and that will allow me to put the gear on there in the right location and all of that. I don't know if these are exactly the same diameter. It really doesn't matter in that case anyway, because I effectively need this piece right here. In fact, I could literally use this piece off of this, basically cut the bottom of this distributor off, as I mentioned earlier, and fabricate it onto here in some way. Perhaps in a way where, this back section is bored and pressed over the end of this for, an inch or so. That's one option. There are others. I'll figure that out as I go along, but there's definitely going to be some machining involved either on the bottom or on the top. If I were to take this mechanism off of the top of the distributor and put it onto this distributor, then we have a little bit of a different problem. And that problem ends up being something where we can't easily protect this from the weather. So this, I can buy a cover. I believe I already did. I think it should be here soon. Anyway, there is a weatherproof cover that fits on top of this. That is solved completely once I get that cover. So ideally, I can use the top of this distributor with some sort of adapter to go to the bottom. I did some measuring. It looks like the bottom part of that distributor is going to just have to be rebuilt. I've got that bar aluminum there. So I'll make something that looks a lot like the distributor on the left. I may have to use a larger bar. I'm just looking at it right now and noticing that the shoulder that it needs, I may not have enough meat on the metal to provide that amount of shoulder for the hold down. So I'll have to look into that. But that looks like the approach. It's going to be, cut off the bottom of the distributor here, build a piece that looks just like the bottom of this out of aluminum, press it onto the bottom of this, put some Loctite on it,
and then it'll be a permanent mount, and that'll hold the distributor together, and that'll allow me to get the timing pulse that I need.